In this video, we're going to talk about how pH and solubility are heavily related to one another. Generally speaking, the solubility of many ionic compounds depends on the pH of solution because the ions in those compounds are themselves acids or bases when they dissociate. Let's look, for example, at magnesium hydroxide and barium fluoride. When these compounds dissolve, they'll make magnesium ions and hydroxide ions, barium ions, and fluoride ions. Now, sometimes the acidic or basic qualities of these ions are going to be really obvious. For example, we can tell right away that if you have extra hydroxides in solution, it's going to be basic. But sometimes it's a little bit more difficult, like with the barium ions. Barium doesn't necessarily change the pH of a particular solution, but fluoride will. And I can tell that because I remember from the acids and bases chapter that hydrofluoric acid was a really common weak acid, which means when the fluoride ions are in solution, they are the conjugate base of the weak acid. So those will act to attack any H's in solution, which they'll steal from water, to raise the pH above 7. Now, where these problems get really tricky is that some salts will mess with pH and others won't. You have to be really careful. It's only the conjugate bases of weak acids that do anything. If you have the conjugate base of a strong acid, for example, chloride ions, bromide ions, iodide ions, nitrates generally, and perchlorates, these guys don't do anything in solution. When hydrochloric acid is in solution, its K value is so large that the reverse process pretty much just doesn't happen. So you don't have to worry about these particular ions in solution. Any of the other negative things you see, you really need to check with a table in your textbook. See if those ions are the conjugate bases of weak acids. Because if they are, changing the pH in the solution can greatly affect how these things dissolve. Let's go back to our magnesium hydroxide example. When magnesium hydroxide dissolves in solution, if it dissolves all the way, losing both of its hydroxides, you can make this particular salt dissolve more if you remove one of the products from solution. The easiest product to remove from solution is the hydroxide. If you add in a strong acid that produces the hydronium ions that will attack the OH minuses, basically, which is a little bit of a pun, doing this, you're going to make the reactants turn into more products because of Le Chatelier's principle. Again, if you lower pH by adding a strong acid, for example, hydrochloric acid to solution, you will make the salt dissolve more. This increases the molar solubility of the magnesium hydroxide. This process works the same for things like barium fluoride, if you add in extra H plus from a source like hydrochloric acid, the hydrogens will attack those weak bases to produce the weak acid. This effectively removes some of the F minuses from solution, lowering that amount. And then according to Le Chatelier's principle, again, more of my salt will dissolve so that I can reach that K value that we desire. Now let's bust a move through a few more examples. In this question, we want to know who is more soluble in acid. Okay, so let's see what kinds of ions each of these compounds makes. My first guy, copper 1 iodide, makes a metal with a small charge who probably won't change pH, and an iodide. Okay, so we check our list and we realize that if you want to look at the acid version of iodide, that would be HI. But HI is a strong acid, so lowering the pH will not help in this particular situation because the I's will not link up with the H pluses. Okay, let's look at another one. In this next example, this would make 2 silver ions and sulfate. Now we just went over in our last example how sulfate is the conjugate base of this guy. So adding acid to solution would attack our sulfates, removing them from solution. So this will help. Yes, more soluble. Okay, now let's look at our zinc hydroxide. This one is a little bit easier to see, just like our magnesium hydroxide example earlier. We'll have our zinc ions and our hydroxide ions. Adding more acid to our solution would attack our hydroxides, removing them. And so yes, this salt will be more soluble in acid. Okay, we have another one. Let's look at this barium oxalate. Okay, so we'll have our barium ions and this ugly ion. And honestly, if I weren't me, I would need to check a list of weak acids and see that yes, this guy does exist on a polyprotic acid list. He'll produce this guy. So yes, if you have extra protons in solution, it will help the barium oxalate dissolve in water. Okay, last one. Calcium ions, lots of them, and phosphates. Okay, again, you'll have to check your polyprotic acid list to see how this one helps. The phosphate is going to be the conjugate base of this particular proton removal. So yes, adding protons to solution will help dissolve our last compound, calcium phosphate, as well. These questions are really hard. I highly recommend you go through every example in the questions at the end of the chapter and that you just practice until it's easy for you to identify when some salt is going to be acidic or basic in solution.